Okay, we're all good, right?
Yes, sir.
Okay. So, first of all, I want to thank Dr. Balchandra Kode, the head of the department, and Dr. Asim Ali Khan, assistant professor in the Department of Civil Engineering, RH Raisoni College of Engineering, Nagpur, India, for organizing this event and also inviting me to present in this event. I also want to thank all the attendees for finding time to attend this event. So I wanted to, take this occasion of National Pollution Control Day to talk about a broader concept of sustainable engineering that is needed for pollution prevention and control. So before I get started, I want to, introduce myself. I'm from Chicago. This is the map of US, where Chicago is. Chicago is a beautiful place. If you never visited Chicago, please visit. I will be happy to show you around. It's a fantastic place for seeing what civil engineers can do, for the society. The last two pictures that you see here are the pictures of my campus. So I am in charge of these two labs, Sustainable Engineering Research Lab and Geotechnical and Geoenvironmental Engineering Lab. A lot of my research is on environmental remediation of soils, sediments, groundwater, and stormwater. And also I deal with waste management and landfill engineering. So, all my research fits into the theme of environmental pollution prevention and control. But I also work on life cycle assessment and sustainable engineering. Here, everybody these days are worried about sustainability and resiliency, but how do you quantify sustainability and resiliency? Those have been my focus. And how do you apply these sustainability and resiliency frameworks to assess, how sustainable is how sustainable are our designs? And my master's and PhD were on geotechnical engineering. My bachelor's is in civil engineering. For the research that we have done over 25 years has been summarized in these 4 books and several journal papers and conference papers that you can see here. So in our research, we we identify what is the problem that we need to solve. We try to come up with a research hypothesis, and we do the bench scale testing, and then we do the large scale lab testing, and then we do the numerical modeling, and then we design the field systems. And we actually go out to the field and try it out whether it works or not. Once it works, then we develop design guidelines for practitioners to use. So our goal of research is to advance the fundamentals, ultimately trying to come up with the solutions to solve the real world problems. I do a lot of experimental research. This is my lab. This is my equipment. And over the years, I had an opportunity to work with many talented students from all over the world. So a lot of my accomplishments are due to these hard work of these students and visiting scholars. Now, today we are celebrating, National Pollution Prevention and Control Day. So on this day, we all recall what happened, Bhopal tragedy. So to remember that India observes this National Pollution Control Day every year on December 2nd. On this day, we need to remember what happened midnight of December 2nd, 1984. Highly toxic methyl isocyanate gas released from the Union Carbide pesticide manufacturing plant, and over 3,000 people died immediately, and over 300,000 people suffered chronic health problems. And this day reminds us to be aware of these environmental issues and importance of pollution prevention and control. You may be dealing with air pollution, not only air pollution, but soil and water pollution is also very important to consider. In response to this tragedy, it's known worldwide, and in the US, U.S. government has passed new regulations on toxic chemicals and operations of industries, and then they enforce them vigorously to prevent any such tragedies. Just to give you some examples of the laws that are controlling chemicals and industries are these, TASCA, it's called Toxic Substance Control Act, Emergency Planning and Community Right to Know Act, because people living around the industrial plants, should know what kind of chemicals are being used in the industry, and risks associated with their exposure. And Occupational Safety and Healthy Act, Resource Conservation and Recovery Act, and CERCLA, or we call it Superfund laws. So these are all the laws that protect people in U.S. And I think similar laws are being passed everywhere to protect people and the environment from the contamination. So no matter where you are, environmental pollution in all forms, air, water, and land, must be prevented or at least controlled. So on this occasion, I wanted to focus my presentation on environmental pollution. And first, I want to talk about what is environmental pollution is, what we are doing now. But I think we need to look at this one in a grand scale. I'm going to present these grand challenges and how we can achieve pollution prevention through sustainable and resilient engineering. And then I'm going to talk about environmental pollution control, because we are having air pollution, water pollution, soil pollution, and we need to control the existing pollution and the consequences of the existing pollution. It could be air pollution, water pollution, or land pollution. And other one is the waste disposal problem that is there everywhere in developing countries. To some extent, even in some developed countries. So I want to just focus on this, the ideal situation of pollution prevention, and then talk about, how do you handle, the pollution that we generate. And just, at the end, I have some closing comments. So let's talk about environmental pollution prevention. That would be the ideal one, right? I mean, you don't want to create pollution, to start off, that will solve all the problems. In US, we have a law called Pollution Prevention Act. It's sometimes called P2 Act. The whole goal of this act is to reduce the amount of pollution. I mean, I'm talking about air pollution, soil pollution, water pollution through cost-effective changes in production, operation, and raw materials use. Basically, this other term for pollution prevention is source reduction. And to achieve this one, we need to really, make sure that hazardous substances don't enter into the environment. For that one, we need to think about using different equipment, different technology, different processes, reformulation or redesign of the products, substitution of raw materials, and also, improving housekeeping, maintenance, training, and inventory control. So these are all the good practices that needs to be done so that contaminants are not entered into the environment. So in order to achieve this one, we practice so-called green engineering. Some of the concepts in green engineering is prevent waste rather than treat it, design for targeted durability, not immortality, minimize toxic reagents and processes, minimize the energy use, minimize the materials diversity, design for recycling and reuse, and view embedded entropy and complexity as an investment. So these things, are being done in the field of pollution prevention. But, to me, these things are not, thinking big. So in order to address this pollution prevention, we need to think big. What do you mean by big? Let's take a step back and look at what is going on in the world. What are the challenges that we're going to have into the future? So one of the biggest challenges that we have going into the future is this exploding population growth. And as the population, grows, you're going to have a lot of consequences. And it's not a theory or fiction. The numbers speak for themselves. So the population has increased tremendously in last several years, and it is expected to continue. And you may reach up to 10 billion people, which is a lot of people on this planet with limited resources. So as the result of increased population, we're going to have a depletion of natural resources, and we're going to create the waste. Everybody throws away stuff. So more people means more waste that is going to be generated. And we're going to have increased pollution, right? Air, water, land, more people, more vehicles, all kinds of things are happening as a result of more people. So we're going to have increased pollution, damage to ecosystem, loss of biodiversity, urban sprawl, economic disparity, and social injustice. So all these things are going to be issues. Some of them are being faced now, and more are going to be coming into the future. So from the environmental pollution prevention point of view, we are talking about some waste that needs to be disposed, and how much is the pollution that is going to be emitted. So, if the population is increasing, things that we are doing are not going to be enough. So that's why I'm saying we need to have a bigger picture rather than our narrow view that we have been having on the pollution prevention so far. The other challenging aspect that we are going to face into the future is the global climate change. And as a result of climate change, we are going to see these extreme events like floods, droughts, wildfires, and so forth. And they are impacting people now, and it's going to impact people into the future. The global climate change is, it's due to greenhouse gas emissions, and these greenhouse gas emissions are increasing at a very, rapid rate. And as a result of that, we are seeing, temperature changes, all over the planet. In some places it's more, some places it's less. So it's kind of uneven distribution of that. And these greenhouse gases, where are they coming from? A lot of it's coming from fossil fuels, deforestation. Is carbon dioxide is one of the greenhouse gases. Methane is another greenhouse gases. Landfills, like the dump sites, all the livestock, paddy rice farming, land use and wetland changes, pipeline losses. And you have other greenhouse gases, nitrous oxide and fluorocarbons. They are coming from different sources. And nitrous oxide coming from agricultural activities, including the use of fertilizers. So there are a lot of sources that are contributing to increasing greenhouse gases. And as the greenhouse gases increase, we are having the global warming effect, and that is causing all these kind of climate change hazards. Again, some places it's extremely dry, some places it's too much flooding, some places, it is too much cold. We have a lot of hurricanes, pollution, starving, wildfires. All these things are happening. Before they were happening to some extent, but with the climate change, these have become really taken off, and a lot of people are being impacted by these impacts. And if you look at the statistics, these incidents, these hazards actually, keep on increasing every year. So it's not a, fluke that, these things have happened one year, next year it may not be happening. But if you look at the statistical data, these hazards, the number of these hazards are increasing. Now, these climate change impacts have, direct implication on the pollution problems that we are talking about. We're talking about pollution prevention and pollution control. So how are you going to handle these climate impacts? If you have excessive flooding, sea level rise, a lot of industries, the chemical plants are located along the coastal areas, and if sea level rises, these are going to be inundated. If you have extreme flooding situations in any parts of the world, you're going to see all kinds of these, environmental degradation issues. So how are we going to do this one? So we need to think about this pollution problem, in a broader context than what we have been doing. Now, just if we think about these grand challenges, one I said is the, population increase. Other one is, this greenhouse gas increase. But if you look at this figure here, you can see there is a correlation between population and CO2 emissions. So more people, more emissions. So if I have to give you one problem that we are going to face or facing now globally is the exploding population growth. So that is going to cause a lot of problems. So of course, environmental pollution, waste generation is going to be of concern from the the focus of this event point of view. So what are we going to do? Obviously, it's not easy to reduce the population. It's a very sensitive issue. How do we do things in spite of population growth? So from this event context point of view, how are we going to reduce the pollution? How are we going to prevent the pollution? How are we going to control the pollution in spite of this increased population growth? So that's the biggest problem. And that's where, people are questioning, are we going to have sustainability or sustainable development? Is that in danger, right? So that's the big thing that everybody is concerned about. So the sustainability or sustainable development, many of you probably know this definition from UN World Commission on Environment, or called Brundtland Commission definition. So per this definition, development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So it's kind of what we're trying to say is, we should meet our needs and we should not compromise the needs of the future generation. So if you have this, increased population, and if we do things same way that we have been doing, the current generation is going to compromise their quality of life, and we are going to compromise the ability of future generations to have quality of life. So this is not a fiction. This is the reality that we have to face as we go into the future. And at a global level, United Nations has been doing a lot of stuff. And they recognize this problem, and they set these sustainable development goals. We need to make sure that we achieve these 17 goals. Let's act on these things, So let's do a lot of different things so that, we can have a sustainable development. And, engineers play a major role in achieving these sustainable development goals. So, American Society of Civil Engineers, the ACE, has given this functional definition of sustainability. So according to that definition, sustainability is a set of economic, environmental, and social conditions. I highlighted this one called triple bottom line that maintains the quality of life indefinitely for current generation and future generations. So that's kind of an essence of the functional definition of sustainability. What I need to do for sustainable development. So this definition kind of gives us the roadmap on what can we do. So we need to really look at economic aspects, environmental aspects, social aspects on everything that we do, and make sure that we get maximum positive benefits and reduce all the negative benefits. So that kind of a framework that we use for sustainable design. I'm sure you heard about sustainable design, and this is valid in any engineering field. So basically, we look at this triple bottom line. So the environmental aspects, economic aspects, and social aspects. So we need to maximize the positive impact. So that's basically what we are looking at as a sustainable option. But other thing that we have to look at in sustainable design is the life cycle. We need to think about where the materials are coming from, how the materials are made, how they are transported, how they are being constructed, how they are used for construction, and then maintenance. And then at the end of the life of the structure, what are you going to do with those materials? Are you going to dispose them in the landfill, or are you going to reuse them? So this is kind of, in brief, what sustainable design is. But sustainable design is looking in the long run. But in the short term, we have these climate change impacts. As I told you, greenhouse gases have been increasing. And then, we are having all these hazards. And then how do we, the infrastructure that we have is not built taking into account of these hazards, climate change hazards. So we have to identify now as engineers to look at these climate changes and then look at the infrastructure. And we need to, develop new practices and standards. The curriculum that we have does not address, climate change impacts in our design. So we need to, think about, changing the curriculum, changing the standards. And then we also need to think about how do we improve our infrastructure so that it can, resist these climate change impacts. So that's where we are talking about resilient design. So I talked about sustainable design. Now, we are talking about not only sustainable design, but in the short term, we need to take care of these, climate impacts, through this resilient design. So what resilient design is all about, the system able to cope, adapt, or grow in the face of uncertain and extreme climate impacts that may occur over the life cycle of the project. So you're talking, whenever the project, whatever the lifetime of the project is, that's going to be longer time anyway in civil engineering, maybe 50 years, 70 years, 80 years, 100 years, whatever it is. During that time, climate is going to change. So what we want to do is when we design something, if an extreme event happens, you may be compromising the performance, but hopefully it does not collapse completely. And then, after that extreme event goes away, then the system should recover to acceptable performance level, or maybe it can improve to the original level, or even get better than the original design situation. So we need to think about resilient design for the new infrastructure, and we also need to think about how we can make our existing infrastructure resilient. So this is where we call it climate adaptation. So you have existing systems, and if I'm expecting a lot of flooding, I know what is the risk is, and how can I mitigate the risk. So this is called climate adaptation. For example, there is a dump site right next to the water area, and because the water is expected to rise and surge level is going to increase, so they constructed this erosion protection system so that you don't have a damage to this landfill system. Now, so this adaptation is like, okay, greenhouse gases are going to are increasing, and then you're going to have these climate impacts, and then you are basically thinking about how to protect the infrastructure. But the long-term solution is to mitigate the greenhouse gases, reduce the greenhouse gases, so that we don't have a global warming area. So for that one, we need to think about high efficiency and low or zero emitting technologies, and develop cost-effective carbon capture and storage emissions, and utilize natural systems. And we need to exchange the information on what ways that we can reduce and mitigate these greenhouse gases. So as you see here, we need to be thinking about anything that we do in civil engineering. It could be a design of structures, design of environmental systems, design of transportation systems. All fields of civil engineering should be thinking about new systems that will reduce the greenhouse gases. I know, a lot of structural engineers, they say, oh, we have nothing to do with environmental issues, right? So all the environmental issues are dealt by environmental engineers. No, this is not the environmental engineers issue. It's for everybody's issue. So whenever we design a beam or column or building or a bridge, we need to think about what materials that we should use so that we have greenhouse gases reduced as a result of that new shift. So also, there can be a lot of things that can be done to make sure that we reduce the greenhouse gases in the atmosphere. The plants is one thing that we can do. And if you have excessive greenhouse gases, there are places where they're considering injecting the CO2 into the deep aquifer and addressing, trying to reduce the atmospheric emissions. But going into the future, whether you're in civil engineering or in any other field, we should be thinking about this sustainable and resilient engineering. What is this? So basically, in the current scenario, we know how to design, do the technical design for, given loading conditions. But that's not enough. So we need to look at the resiliency. So we need to consider these extreme events that are happening, and maybe the extra loads or whatever this additional burden that is going to be coming onto the structure. So we need to make sure our technical design can take into account of that one. So if you do that one, so basically you're going to have this, technical design that we can call it, safe and resilient design. And then this triple bottom line framework, this is the target of making sure, we have a sustainable systems into the future. So we need to look at triple bottom line. You need environmental impacts, social impacts, economic impacts. I just want to mention that these environmental impacts include greenhouse gases, air pollution, waste generation, and so forth. So in a way, we are addressing the climate, but this is going to take a long time. So, within the short time, we need to think about addressing the climate impacts. So that's where resiliency comes into picture. So, but going into the future, we need to look at the sustainability and resiliency. Therefore, we need to make sure we design sustainable and resilient infrastructure. So today's focus is on environmental aspects, right? So when you talk about sustainable design, we need basically looking at this triple bottom line. In the triple bottom line, environmental aspects is one of the dimensions of this triple bottom line. And in these environmental dimensions, as I mentioned, we are trying to reduce the greenhouse gases, reducing the pollutions and waste generation. And then there are other, environmental benefits that we are looking at it. Okay. And in a broader sustainability context, you need to look at social and economic aspects. But for the sake of today's presentation, let me focus on environmental. So if you can look at this pollution prevention from the sustainability angle, you are looking at the big picture, right? Not just conventional way, hey, I want to practice some green engineering, that's going to solve the problem. That's not the case. So the pollution prevention, from my point of view, looking in a big picture is looking this way. So looking at the environmental sustainability. So it, through life cycle, and environmental sustainability. That's what we are looking at. So life cycle, as I mentioned, not looking at one stage of construction. We need to be looking at the entire life cycle. As I've shown you before, we need to think about raw material acquisition, manufacturing, operational use, and recycling, and all those things. For each of these stage, we need to think about what raw materials are needed, what energy is needed. As a result, we are producing whatever we intended to. But in these processes, we're going to emit these things. These atmospheric emissions, waterborne emissions, and solid waste. So these are the environmental pollution. So it could be air pollution, water pollution, or the waste, soil, land pollution. So what we need to do is this life cycle assessment gives us a very broad, comprehensive framework to look at whatever we are doing, what could be the environmental pollution outputs are. And then you revise your design so that this environmental pollution could be minimized. Okay, so there is no absolute design where you have a zero emissions. But the bottom line is, if you have a design, what can I do? Maybe material substitution or do something that can reduce this environmental pollution. So this will give us a very strategic way of environmental pollution prevention. So in the life cycle assessment, you need to define what is the boundary. So if I'm looking at, say, manufacturing of the paper, should I look at just the manufacturing of the paper, or whatever the feedstock that I need for manufacturing, should I consider that one? So I have these different boundaries. Just should I do the assessment just for the plant itself, or should I look at expand the boundary to look at the energy and chemical resources that I'm getting offsite from offsite to this plant, or you can look at other situation, looking at all the different aspects that I shown here. So basically, you can do the analysis to different scales depending upon how much data that you have. So the red is one like a narrow focus, and this blue one is expanding the scope, and then this green is further expanding. And if you really want to be thorough, you should be considering the entire the entire diagram as your boundary for analysis. So the point that I'm trying to say is not just look at your little thing. You need to be looking at this systems approach, this broader approach when we are looking at these assessments. So this life cycle assessment is there's a standard ISO 14040. So it's a well-established methodology. So you define these four phases, and then in the outcome you get these environmental impacts. So environmental impacts could be depending upon the impact assessment method that you're using. So for your system you can look at different components or overall what the design emissions are, and the whole idea is if you have options, which one is emitting less. So that's like that we are preventing the pollution. So that's the best way to look at it. So that's only like environmental sustainability. But remember, we have immediate issue of addressing the resiliency due to the climate impacts. As I said, if you don't consider these climate impacts, you're going to have a lot of environmental pollution, as I showed you in the picture. So if you have excessive flooding and those things, you're going to have a problem. So we created a new framework, how an engineer can integrate sustainability and resiliency, and think about developing sustainable and resilient infrastructure designs. So you can find more information from this publication. So you need to have a roadmap. Okay, I want to do sustainable and resilient design. Where will I start? So this kind of gives you framework, roadmap on step-by-step methodology on how to go about quantifying the resiliency and sustainability from design, and you can change the design based on that. So some general principles of sustainable resilient design is, we need to think about using the natural, designing with nature. Anything you go against the nature, that's going to backfire us one way or the other. And we need to make sure, the systems are adaptable, flexible, and we need to think about systems approach, look at the holistically what we are doing rather than just a small component. And we need to be thinking about green chemistry, green processes, green materials, renewable energy, life cycle impacts, the energy, materials, greenhouse gases, pollution, waste elimination based on the life cycle assessment that I mentioned. You need to also look at economic and the social responsiveness. So in my opinion, this becomes a holistic strategy for pollution prevention rather than the current practice that we have. So I highly recommend you to look at this book. If you are not familiar with sustainable engineering, I want you to look at this book and learn more about sustainable engineering concepts. So let me go over quickly about this second topic of environmental pollution control, right? So we have existing pollution, and so some pollution is going to keep on occurring. So it is important to control it, because we all know that environmental pollution is really bad for human health, right? So it could be air pollution, water pollution, or land pollution. The bottom line is people are going to get all these diseases and they're going to die, right? So we don't want to have loss of life as a result of this environmental pollution. So not only public, but the environment could be affected highly negative way by this environmental pollution. And I don't have to emphasize this one. You probably have seen in your real life, these kind of impacts. So when you say environmental pollution, it could be air pollution, water pollution, land pollution, or waste pollution. So air pollution, as the department had mentioned, the Delhi recently had worst air pollution problem, right? So there are a lot of sources of air pollution. And typically, air pollution is categorized into primary pollutants and secondary pollutants. And there are laws, in US, we have a Air Pollution Act, Clean Air Act. And then all these air pollutants like a lead, sulfur dioxide, ozone, carbon monoxide, nitrous oxide, particulate matter, and maybe, other, toxic gases could really, harm the public health. And this air pollution field is pretty old, and there are many treatment technologies that have been developed for controlling the particulate matter and for controlling the gases pollutants, and they are applicable for stationary sources, but there are technologies for addressing the emissions from mobile sources. So I don't work on this air pollution, but there are courses that are taught in the universities on air pollution and the treatment technologies. In my lab, we are doing this problem of gas emissions from dump sites and old landfills, or even the new landfills. So, when you have waste disposed, the waste is going to degrade and you're going to get methane, carbon dioxide, H2S, and other kind of gases. And even, if you don't have any engineered cover system, they're getting into the atmosphere. Even if you put a cover, sometimes you get fugitive emissions. So this is a huge problem. And, in the US, landfills, or even though they have engineered cover, they are third largest contributors of methane emissions, causing global climate change. So it's very important to consider this one. So in our research, what we are trying to do is we are trying to create this sustainable and innovative cover system. We call it geochemical cover system that uses the biochar amended soil to convert the methane into CO2. And then we have a slag layer, that steel slag layer, that converts the carbon dioxide into carbonate, and even H2S could be sequestered in the slag layer. And at the end, basically, you are getting zero emissions from the landfill. So this is the type of research that I do. This is the one project I just wanted to share. In terms of the water pollution, a lot of you know about this. Sources are considered point source pollution or non-point source pollution. Point source pollutions are kind of, you have a handle on where they are being released, so you can do something about it. Non-point source pollution is really a complicated issue. And then when you talk about water pollutants, there are a lot of things, right? Pathogens, organic matter, inorganic chemicals, organic chemicals, and nutrients, right? So, they are all bad for human health and the environment. So we really need to control these things or treat them. Again, there are many water treatment technologies, activated carbon adsorption or ion exchange, advanced oxidation systems or membrane treatments, chemical oxidation reduction. So there are many technologies. Again, like air pollution field, water pollution field is very old, and a lot of things have been done, and we teach our students these technologies. Of course, the new technologies are needed for emerging contaminants and so forth. And in my lab, we don't do the water and wastewater, but we do the stormwater pollution problems. For example, in Chicago, all the stormwater, when it rains, all the water from the parks and roads gets into the beach, and the beach gets contaminated. And on the parking lots and everything, you have cars, some leakage of oil from there. You have roads, and we put the salt during the winter. And you have this greenery that we use pesticides, and these birds, they poop, and all the biological contamination, all that goes into the beach, and then beach is contaminated. And of course, people love to go to the beach, and you don't want them to be exposed to this contamination. So in our lab, what we came up with is this new technology. Basically, we call it in-ground permeable reactive filter system. So instead of directly discharging into the lake, it goes through this underground filter system, and we need to select the filter media based on the contaminants that are expected in the stormwater runoff. And then we actually did the project. We looked at what contaminants are coming typically in the stormwater, and we built this one. These are, in ground. Basically, this is the research we wanted to prove. So instead of burying into the ground, so we had a little bit elevated, but in fact, you can put them under the ground. And then we found out that this kind of technology can be used in urban areas because we don't have, land to use other conventional technologies. So the filtration technologies are most feasible in this case. The land pollution is a big problem. If we discriminately, discarded our waste and we contaminated the land, soil, and then contaminants seeped into the ground, and groundwater is contaminated. We have good statistics in the U.S., but developing countries like India, China, and Brazil, they don't have a track of how many sites they have. But definitely, there are a lot of different sources that cause the contamination of the soil and groundwater. And one of the major things is the land disposal of solid and liquid waste. And then when you have contamination, humans are going to be, let's say you have a contamination and that's going to leach. It could contaminate the groundwater. You may be, contaminating the streams, contaminated groundwater. People may be drinking it. So there are many ways that people and the environment is going to be affected by this one. So what kind of contaminants you find in soil and groundwater? All kinds of things, inorganic contaminants, organic contaminants. So these are all highly toxic. If you are drinking the contaminated groundwater, you can get health issues. And people, if you are playing, in those areas, they're going to get diseases. So this is the problem that we need to address. So as an engineers, we need to, remediate these sites, treat these sites. So depending upon how the site is, you could have a big dump site, that treatment needs to be done differently. If the contamination in the soil, didn't enter into the groundwater, there are technologies for that one. And then if it went into the groundwater, if you have high concentrations, you need to look at the source zone remediation technologies. And then if you have a plume, dilute plume, then you need to look at different technologies. So there has been a lot of research done on these technologies, and I spend a lot of my research on these technologies. So if you have a contamination, how do you contain the waste so that it does not spread? So we use this slurry trench vertical cutoff walls, and then we can put the covers and make sure that the contamination is contained and has no exposure issues. If the soil is contaminated, we used to dig out that soil and put it in a landfill, and that is not considered as a treatment technology. It's just transferring the problem from one location to the other location. Now we are, developing a lot of these in situ soil remediation technologies. You don't have to excavate the soil out. You can keep it in the ground and treat them. There are different technologies these. And then if you want to excavate the soil out, and you can treat it at the site or off site using these different technologies. So these are all the technologies that have been developed. Even research is going on to make these technologies more efficient and less costly. So a lot of my projects deal with these kind of technologies. And groundwater. If the groundwater is contaminated, previously we used to just put in pumping wells and pump the groundwater out, thinking that the groundwater gets remediated, but that is proven to be wrong. So as a result, we have all these different alternative technologies depending upon the contamination. We can use these technologies to clean up the groundwater. I mean, some areas, groundwater may be the only source of drinking water. So these technologies are absolutely essential to make sure that groundwater is cleaned up and people are drinking relatively clean water. So if you are interested in knowing about remediation technology, I would suggest you to get hold of this book and read this second section, contaminated site remediation. It explains all the different technologies I just mentioned. The waste disposal problem is a big problem. People, we used to do it like this in the US long time ago before we had regulations, and we realized all the problems that the problems that this kind of disposal causes. In developing countries, you still don't have engineering landfills. This kind of a disposal practice keeps on happening now. You have a lot of dumps. So, that can lead to a lot of problems. You have air pollution, you have surface water pollution, you have infiltration, soils getting contaminated, groundwater getting contaminated, you have vapors coming up into the, neighborhood houses, and then groundwater, drinking water, even streams. Huge problems, with this kind of things. When you're talking about the waste, you may be talking about the garbage that people, dispose of every day from their houses. We may be talking about hazardous waste disposal. Where is this waste going? If you don't have a separate collection system, this may be mingled with municipal solid waste. And the electronic waste, where is this waste going? This has a lot of metals and organic contaminants. They could leach into the soil, they can leach into the groundwater. So how are you handling that one? Medical waste is a huge problem. How are you disposing of the medical waste? How are you disposing of the radioactive waste? If you think about nuclear power is is the way to go, because it does not produce any greenhouse gases, but it produces this radioactive waste. How do you handle that one? And if you dispose it off, then you're going to have a huge problems with radioactive waste contamination spreading all over the soil and groundwater. This disposal, these dump sites should not exist. Whenever I see dump sites anywhere, I get really irritated, because at this time, at this age, we know that these things are really problematic, and we should not be allowing the open dumps. Now, in the US, what we did is, if you have these open dumps, if it's a large area, obviously you cannot excavate all the material out, and you could have a lot of problems just excavating and all those things. So generally what we did is we put a slurry walls all around so that leachate is contained and does not cause contamination spreading and contaminating the groundwater. And then we put a cap on the top of it so that, it is isolated from the surrounding environment, and we put the soil and vegetative cover layer. And if the waste is still degrading, we will have a gas management system. And this, I'm showing you the picture of one of those kind of landfills that have been closed. So you can see, it's greenery and looks more beautiful than exposed waste. And it's a considered recreational park. You can people come here and it's high point and they can get a good view from there. So this become a attraction. And if it is a small site, and if the waste is degraded and if you don't have any contamination, maybe you can do the mining and then recover the materials and clean up the site and use the site for beneficial use. But if you have a large site, a lot of waste, and a lot of mixed waste, and it's very hard to separate them out. And the mining is not beneficial. I mean, not a cost economic point of view, it does not work out good. You always lose money by doing this. But if it is good for conserving the natural resources, maybe we can do that. So if we create the waste, we should not be putting in the dumps. So what do we do? I mean, if we cannot prevent generating the waste, so we have engineered landfill systems. So these are, this field is well developed. You can have a bottom liner, side liner, leach collection system for the waste, and then for the cover system. And that can be done. And you have a leachate collection system, gas collection system, groundwater monitoring system. So these are now, very, very well engineered systems. So many of these are built in the US. They have been monitored for decades, and they are shown to be protective of human health and the environment. And then we are looking at how do we accelerate the degradation of the waste by using this leach recirculation concept. So this is our project. So instead of just dumping and walking away, can we make them as like bioreactors, in situ active waste treatment systems. So if we can do that one, we can have a lot of benefits. We can generate a lot of gas, so that can make it energy, gas to energy plants feasible. We can address the leachate. We can, stabilize the waste quickly, and then we can probably use the site for beneficial purpose, like a golf course or like a nice park. You can do that, and all these things are well established. You don't need to start from the scratch. And we teach courses on those things. The last point I want to mention is, if you are not disposing the waste in the landfill, what can you do? Ideally, we don't want to put anything in the landfill or dump site. So we should be, recycling these materials. So in my lab, with my collaborators, I worked on these different types of waste materials. And what our research was to use this as a beneficial materials for construction. So as you know, there's a large demand for construction materials, all over the world, and in particular even in the US. And especially sand, gravel, crushed rock. There's a with the expected construction projection, we need large quantities of this, and we are running out of these materials. So the only way to make this construction possible is to use these recycled materials as substitute for sand, gravel, crushed rock, or other type of the materials that we conventionally use. So in our research, we try to take a very systematic approach, because just because you have waste and you want to use it, you don't want to cause a problem from environmental perspective, right? These waste materials could have contaminants in it, pollutants in it. You don't want to use the polluted waste material and spread all over and spread the contamination problem. So we follow a systematic approach. We identify a waste, and then we look at what kind of applications that we can have, and we do the extensive lab testing, and then we try to do the demo, including the conventional properties, also the leaching characteristics or contamination potential. And then we try to develop the standards, and then do the sustainability assessment, and show them that these are safe and similar or even better materials than the conventional materials, and they are economical to use it. So we can make people to use these materials if we can show those benefits. And not only doing the lab experiments, but actually going out to the field and demonstrating that these things work. So a lot of research needs to be done out in the field to show that these materials really work in applications. So what we are targeting is this linear material economy to the circular economy. So so far it has been we extract the resources and then we use it and we throw them at the end. So ultimately, all the materials are ending up in the landfills or incinerators. But the idea of this circular economy is, we extract it as much as we need, and then we use them. And then instead of disposal in landfills and incineration, we keep recycling it. So once the material comes into the use, and that never becomes a waste. So we keep on using it again and again and all those things. So with that whole context about environmental pollution, um, you know, I don't need to overemphasize the importance of controlling the environmental pollution to protect the public health and the environment, as well as sustainable development. Right? If you are going to have these environmental issues, you cannot really progress. And as I mentioned, we really need to look at this holistic, broader view for environmental pollution prevention. So that is, we need to practice sustainable and resilient engineering to realize this environmental pollution prevention benefits. And we need to, as a prevention side and pollution control technologies, we need to relook at, all the technologies that we have. Are they sustainable? Are we getting net environmental benefit out of that one? Looking at, the project at a little bit larger in scope, not just looking at, okay, treatment facility, but, all the things that go along with that one. So are we getting really a net environmental benefit out of doing that, implementing that technology or not? And these technologies have to work under these climate change conditions. So, see if they work or not. So what can we do to make them adaptable? So whether you're talking about air pollution treatment, water treatment, land treatment, waste management strategies, so we should be thinking about sustainability and resiliency so that we can address both prevention and control. So going into the future, more and more people are talking about promoting engineering with nature. So we need to harness the nature as much as possible instead of the traditional way of doing the things. So a lot of places, the sustainability and resiliency are not required in design codes and other things that people use it, but hopefully very soon they will become codal provisions or regulations. So that time nobody has nobody can escape from doing these things. But meanwhile, it's our moral responsibility to do the right projects and do it right. Even though codes are not required, but these are the right things to do it. So we need to convince our clients. And as a professional engineers, holding high ethics, we should be looking at these things. So before I end my presentation, I just want to mention that I organize a international webinar series on every Friday. It talks about this polluted land, waste management, sustainability, and resiliency. I highly recommend to attend this. It's on Fridays, 7:30, I think 8:30 p.m. India time, and 9 a.m. Chicago time. So it's a nice way to interact with other researchers working on sustainability and resiliency. And these webinars have been going on since mid-January of this year. So there are more than 50 webinars that have been recorded. So please go to this YouTube channel and see all the topics. And if you are interested in any of them, you can view them. And you can use them for your educational purposes, in your classrooms and meetings and other things. So the whole idea was to learn from each other, and this pandemic gave us the opportunity to have these Zoom meetings and and be able to have presentations from people from all over the world. So with that one, I'm not sure if we're going to have time or not, or if you are resident to ask any questions, feel free to send me email. This is my email address. You can connect me on the Twitter, Facebook, and LinkedIn. And these are my lab websites. So please go to these websites and you can find information related to our research and publications and so forth. I want to thank you all, and I will be happy to take any questions. As I said, if I don't get a chance to, answer your questions, please feel free to email to me. So with that one, again, I want to thank the organizers for, making everyone aware of, this National Day, and we all should strive to towards environmental pollution prevention and control. And I congratulate the college for